Everyone. Happy to be here. This is our second FinDEVr. Always a pleasure to be part of this. So we live in an identity economy. That's what we think we have all as everybody that offers services has to be aware of who are the people they are dealing with, especially if you are a financial organization. So if you are a financial organization, you really need to understand who you are doing business with. And the way that we do this is we try to answer 4 different questions. So the first one is, are you dealing with a real user? Second one is that person that you're dealing with in the online world actually owns the information, or is it authorized to use information that is there? The third question is, can you actually, from the regulatory perspective, can you actually do business with that person? So is it sanctioned or is it a minor, but you have to know whether you can, from the legal perspective, do business. And number 4 is, what is the risk? So if it is a real user, if it owns information, if I can do business with that person, then you as a business need to understand what is the risk of doing business with that person. So the solution, or the way that we approach this, is with the concept of trusted digital identities. If you are following sort of the world of RegTech, the world of identities, you're going to see similar companies talking about trusted digital identities. For us, again, a trusted digital identity is an identity where you can answer those 4 questions, and you as a financial organization doing financial services, you can answer those 4 questions. So our database is about 200 million identities at the moment, and it's growing daily, and it's a worldwide database. So briefly, what is it that we do? We analyze financial transactions, and this could be for the purposes of reducing fraud, for automating the online onboarding, so if you're doing KYC, or for automating compliance. So we evaluate money transfers, so if any transaction that involves moving money from one person to the other, or taking money out of a digital wallet, or funding a digital wallet, for example, all of that. We evaluate payments. So we work with e-commerce companies to evaluate transactions, credit card transactions or ACH transactions, and we help customers automate the online onboarding process. So we offer services for fraud prevention, for customer onboarding, including the KYC, and transaction monitor for anti-money laundering and sanction screening. So we do all of this through our patented technology, which is called electronic DNA. And the idea is that how identities, you define digital identities and how those identities are connected among each other. Each identity is really a connection of different attributes and different parts of what in the electronic world and in the physical world describe a user. So it could be your devices, it could be your passport, it could be your driver's license. So all of that is part of who you are in the electronic DNA concept. So that means that from the feature perspective, then we have a database of pseudo-anonymized digital identities. We take the information from all of our clients, so we have a concept of what we call crowdsourced reputation. Those graphs that you see there, every identity that you deal with in our database has a graph of information. And we score those transactions based on the complexity of the graph. The higher the complexity of the graph, the higher the risk of the transaction, which is actually sort of the subject that we're going to talk about in the demo portion of the presentation. So all of this is what we can do on identity link analysis, which is what we are unveiling later on, and it's all in the cloud. So it's a SaaS-based platform. When we don't have information about a particular identity, then we have an ecosystem of partners. So we have 20+ partners that we do business with, and those range from ID data validation, so companies like Experian, Idology, ID Analytics, Buró de Crédito in Latin America, Neoway, etc. We do document validation, and that means government ID, so companies like MyTech or Authentics are our partners. 2-factor authentication, so we can do verification through phone, we can do verification through mechanisms outside the data that we're seeing at the moment. Social network analysis, deep and dark web analysis, so that data is part also of it. So all in all, through our partners, then outside our database, we get access to billions of identities. We get also worldwide coverage of data validation. And we get basically every document issued by any government around the world that we can validate. So the platform is all REST API based. It's real-time processing, so every transaction that we're evaluating, We're going to give you a result in real time. We have a very developed, well-user interface for financial crime analysis, and we support operational workflows to file SARs and different kind of things. This is our kind of screenshots of how the platform works, and I wanted to show you this because what we're going to show next is actually open source code that you can download, but that's how the actual platform looks like from the user interface perspective. What you're going to see next is what we have open up for developers so that you can download code and start playing with the technology. So with that.
So today, to support our 200 million identities, we have a graph with approximately 500 million vertexes representing users, payments, addresses, devices. 750 million edges connecting those. The edges themselves contain information such as the type of relationship, what kind of transactions made that connection, recency, frequency data, and this is all cryptographically anonymized. The Entity Link Graph API allows you in real time to extract from our database the information about the entities involved in your transaction and get the metrics, the reputation, and the score from those. You can then, if you are reviewing a transaction, pull in real time again the updated graph for that transactional information. Because, as we say, our identity database is growing and reputation growing on a daily basis. Additionally, you can retrieve the raw graph data, so you can do the visualizations that we're going to show. So the demo is going to illustrate something called structured layering across 3 different clients of ours. Structured layering is a technique that money launderers use to hide the flows of money, to break down transactions into smaller chunks so that they fall underneath regulatory boundaries. Our bad user, Magdalena, is going to build up some reputation at an e-tailer. Magdalena is then going to open an account at my virtual currency exchange. So it's from this perspective we're going to look at the transactions in the demo. At a third client, virtual currency wallets are going to be funded from credit cards. Transfers are going to take place to Magdalena. Those transactions, those credit card funding, are going to go bad. And finally, there'll be a transfer out. So you don't have to keep all of this in your head. Our crack marketing team has come up with a series of props so we can follow along.
That's right.
There are 2 basic requests that we're going to see during this demo. There is a transaction evaluation, that top one, where you are sending information about the transaction itself. And secondly, a get, which is retrieving the information about the particular graph. Okay. Skip over those. So to the demo. Backstage, I ran a couple of transactions. Up here, I'm going to create transactions over on this side that created an entity graph for our user. So as Jose said, this is sample code. This is not the platform UI that you're viewing, but it is open source code that we're giving away to illustrate how you would use our APIs. So this is an entity graph. We see that we have a user account, a payment instrument, an address, and a device. What's interesting from a demo perspective is that as my virtual exchange, we haven't actually seen any of these. So this is here for illustrative purposes of building the background identity. The colors are representing the reputation. The links, the colors of the links are representing the kind of transactions. So whether it's a KYC, relationship billing, shipping relationship, a payment transaction, or transfers. So praying the demo gods are going to work. What happens next is Magdalena opens an account with our exchange. So now we can see that some of these entities have been involved in our transactions. So we can see the details behind that. We're actually doing a join between the raw metadata in the graph and your transactional data. So we have the addresses, the account names, and card numbers. available. So, moving on to a third client. Let's see, where's my mouse? This is the funding transaction, where a credit card is being used to fund a Bitcoin wallet. Let's see, one more click. What's interesting here is the arrows on the relationship. We understand direction within the transfers, so we can follow the flow of money through our entity graph. This funded Bitcoin wallet then makes a transfer to Magdalena, and that is where we now see how, if I click, how this set of entities has joined with a money flow into the Magdalena user. We'll run a number of other transactions which are doing very similar things. So in money laundering terms, we're adding Smurfs, actually. So if we, once again, look at the graph, we can see there are now significant flows of transactions into Magdalena's account. Within our own platform now, we would be beginning to generate money laundering alerts. So this would be beneficiary volume or frequency.
Hold on.
Can't keep up?
No, I can keep up. Hold on. Get in there, get in there.
When I get nervous, I talk fast.
Yeah, that's right. There you go. All right.
Now we're good. Okay. If we look at this graph actually from the exchange's perspective, if we were building this graph, even if we could build this graph of relationships ourselves within our data, just a small subset of what the entire graph can be seen. Okay. What happens next is a number of those transfers start to go bad. There start to be chargebacks on those funding transactions. So if I once more update the graph, we'll see the reputation has been modified on a number of those entities. Those are the ones that were directly involved in the deposit. And finally, we have the transfer out to another Bitcoin address down here on the bottom right. What's interesting here is the Bitcoin itself that we can see, it looks fine. It's just a Bitcoin wallet. But there's a connection at the other client to a user account which has been tagged with the sanctioned label. This means that this particular user account has at some point been a match on a sanctions list. So from my virtual currency, my virtual exchange's perspective, what's going on actually looks reasonably okay. There's some cause for concern with the reputation, which is actually derived from the other client's transactions around the edges. But if you can see the full picture, this starts to become very concerning. It may not be a regulatory risk, but there is certain business risk. Did you really want to be involved in a transaction that is potentially ultimately funding a sanctioned individual? I mentioned that we understand the direction of the flows. This is another way of viewing the graph where we have extracted just the relationships which are transfers, and we can very explicitly see the money flows within this user base. If you want to try it out, we've made this easy. Contact support for a sandbox account. The user interface, all the access to the APIs is available as open source software. So it's on our GitHub repository. The APIs are documented using Swagger, which is really cool because you can interactively access the APIs from within the documentation. It will also, you can take these definitions and generate client code itself. we've made it easy to upload sample transaction data. There's a CSV format where you can upload some sample transactions, and then you can run the visualizations. This is a little node app locally and view the identity link graph. Okay, that's it. Right on time.
Right on time. Let's see, questions. How do you handle incomplete cash flow data if not every participant uses your platform? Well, we can see what we can see, right? So we have the transactions that are from our clients. So we have many clients that are money remitters, for example, where you have both ends of the transaction. So we model as much as we can see, and we use our data partners to pull in as much data as we can see. Now, as we have more clients, then that data becomes richer, obviously, and we can have further analysis on that. Your graph sounds like a GDPR nightmare. What are you to be compliant? So there's actually a lot of work that was done architecturally to not have the details of the data. So in fact, we work with many companies in Europe, many banks that, and we have passed all the different privacy laws and everything, because the way that we architect the data, we actually don't have the data itself. We have cryptographic representations of the data that we can use for comparison and we can use to aggregate data itself, but we don't actually have to deal with that part.
So all of the data within the graph metadata itself, it's all hashed, so we can match against it. And this is, you can think of this as being one data set. The transactional data, which we use to derive for you the addresses, the names, etc., that's all AES 256 encrypted in a different data set. That data set could stay local, where we share the graph data itself, which is all entirely cryptographically secure.
Can you have user data living in other countries like China or Russia? So what Karen was saying, there are two layers of data. One is that we call transactional data. The other one is electronic DNA itself. The transactional data, as somebody points out, it cannot leave the country. So we actually have to have data centers both in those two countries where we actually have very large customers. But the data that can share is data that is not representative of user in a way. So nobody can actually understand who the user would be based on that data. Not me. Definitely not me, but somebody in the team can actually do very good job at it. Thank you very much. Appreciate the time.